So this is going to be the key for the mixed review from yesterday. All right, so we're going to solve all these questions. If you're not sure how to do some of these things, please contact me and let me know so I can try and help you out. All right, so again, these solving equations is just like solving every equation you've ever done in your life. It's just now we're doing it with trig identities. Okay, so the first thing we're going to do is we're going to add sign. Oops, forgot to put the pen on. We're going to add sign to both sides. So we have 2 sine of x plus root 2 equals 0. Now to get sine by itself, we're going to subtract root 2. So 2 sine of x equals negative root 2. Divide both sides by 2. And sine of x will equal negative root 2 over 2. All right, from here, again, you should have your unit circle out because this is where you need the unit circle. So sine, again, is a y value, so you're going to try and find out what radians are going to be where y is negative root 2 over 2. And there are 2 of them. It's going to be 5 pi over 4 and 7 pi over 4. That's it. Number 2, first step is you're going to subtract the sine of x the other side. Now, this does not get rid of the other sine of x, because the other sine of x is being multiplied by cosine squared. It just puts 1 next to it. All right. Now, hopefully what you're recognizing here is that you have a sine of x here and here, and you can take it out. You can do the greatest common factor of sine of x. That leaves you with cosine squared minus 1, and that all equals 0. Now that you have 2 separate factors, you set them both equal to 0. So sine of x equals 0, and cosine squared minus 1 equals 0. So cosine of x will equal positive 1. All right, should be squared though, sorry. Then we're going to square root both sides, and cosine of x will equal, now again, remember when you square root both sides of the equation, you have to do plus or minus. All right, now that we have that done, I'm going to find out where sine of x is 0, and where cosine of x is either positive or negative 1. Okay, so for the sine of x equaling 0, that's going to be in 3 spots. It's 0, pi, and 2 pi. And for cosine of x equaling positive or negative 1, that's again in 3 places. 0, pi, and 2 pi. Number 3. This is just a quadratic equation with a sine function in it, so we can factor it. So we have 2 sine of x and sine of x. All right, that gives you the 2 sine squared of x when you multiply those together using distributive property. To get the negative 1 in the end, we have to have 1 times 1, because that's the only thing that's going to give you 1 when you multiply that. And you have to get a negative 1 in the middle, so this one's going to be negative and this one's going to be positive. Okay, so that's the factors of our equation in number 3. Now that we have the factors, we're going to set them both equal to 0 and solve for sine. So sine of x will equal negative 1/2, and sine of x will equal positive 1. Now we're looking for the y values on the unit circle that are going to be either negative 1/2 or positive 1. So for negative 1/2, you're going to get 7 pi over 6 and 11 pi over 6. And for 1, you're going to get just one of them, pi over 2. All right, so for question 4, very similar to the question right above it in question 2, except we don't have to get the sine value on the other side, but we do have 2 sines here, so we can take the greatest common factor out, which would be sine of x. What would be left over is the 2, the cosine of x, and then a plus 1. All right, now we have our 2 factors. We can set them both equal to 0. All right, so the sine of x equals 0 is done. For the other one, we have to have cosine of x. We're going to subtract 1, and we're going to divide it by 2. And now that one's done. So now we got to figure out where sine of x is equal to 0, which we have right above us. at 0, pi, and 2 pi. Then we have to find out where the x values are negative 1/2, and those are in two spots, 2 pi over 3 and 4 pi over 3. All right, next one's a little complicated, but there's a hint for you. So we're going to take our our cosine squared in here and use our hint. We're going to replace cosine squared with 1 minus sine squared. So we're going to have 2 stays, and then replace the cosine squared with 1 minus sine squared. I'll put theta. And that's going to equal 13 sine minus 5. Now some of you might be asking, what's the difference between x and theta? Nothing. It's just a variable. Doesn't make a difference which one you use. I could change it to be x's. I just didn't. All right, so back to the equation. We're going to take this 2 out in front, and we're going to distribute it to the 2 parts inside. So it's going to be 2 minus 2 sine squared equals 13 sine theta minus 5. Now I want to get everything on the one side of the equal sign. Now, usually I'd bring stuff to the left, but because my 2 in front of the sine squared is negative, I'm going to bring everything to the right. So I'm going to subtract 2 and add 2 sine squared. So that means all that stuff on the left will go away. I'm going to rewrite it on the left anyway, just because I want to. So I'm going to have 2 sine squared, all right, plus 13 sine. And then negative 5 minus 2 is going to be negative 7. So that's our equation. Now this one's a little more complicated because it's more of an advanced factoring type of problem. All right, it's not too bad because all the numbers are prime numbers. So to get 2 sine squared, you're going to have 2 sine, and then sine. And the factors of 7 are going to be 1 and 7. The question is, where do they go? So we need to be a 13 in the middle. Here's our 13. So that means 2 times 7 is 14. Minus 1 is going to be 13. So those are going to be our 2 factors. Okay, now you'll notice one of the factors, sine will equal negative 7. Well, negative 7 is not on the unit circle at all. It's too big. So that one doesn't even exist. So we can cross that one off. But we do have to solve for the other one. So we're going to have sine of theta is going to equal, we're going to add the 1 and divide it by 2. Okay, so then we find out where the y values are 1/2, which is at 2 spots, pi over 6 and 5 pi over 6. Okay, the last equation is this one. So this has a couple things. One, you have a square root in the middle of it. And this is a radical equation plus a equation with the trig identities in it. Okay, so what we're going to do first is we're going to add the square root sign to the other side. All right, what that does is gives us sine x equals the square root of 1 minus 3 sine squared x. Okay, now that I did this for a very specific reason. I wanted to get the negative sign out of there. Okay, so by adding it to the other side, now there's no more negative. Okay, because it just makes everything a lot easier to deal with later on. Okay, now to get rid of that square root sign, I'm going to square both sides of the equation. That means the square root and the square root will go away, and we'll have sine squared x equals 1 minus 3 sine squared x. Okay, now what we have is we have both signs are squared, so we can add the 3 sine squared x back to the other side. And then 1 sine squared x plus 3 sine squared x is 4 sine squared x. And that equals what's left over, which is the 1. Now we can divide both sides by 4. So we have sine squared of x equals 1/4. And to get rid of the square root, to get rid of the squared, we're going to square root both sides. So we'll have sine of x is equal to, and again, because we did square rooting both sides, you have to put plus or minus. And then the square root of 1 is 1. The square root of 4 is 2. We're finding out where all the y values on the unit circle are going to be positive or negative 1/2. There are 4 of them. There's pi over 6. There's 5 pi over 6. 7 pi over 6. And 11 pi over 6. So those are your equations. All right. Next we have the inverses that we did on Monday. Yeah, Monday. Okay, so again, you're going to need your unit circle for these. And again, you got to remember that each one of these, if you're doing the inverses, has a specific domain you can and cannot be in. So for sine, it's the right half of the unit circle. Again, if you go down, you're going backwards. So if we're looking for negative root 3 over 2, it's in the 4th quadrant of the unit circle, but we had to go backwards to get there. So it's going to be negative pi over 3. Okay, you might be thinking, oh no, it's, what is it? 7? No. 5 pi over 3? But it's not. Okay, because you had to go backwards. All right, the next one, you got negative root 2 over 2. For cosine, you can only use the top half of the unit circle, so this one's going to be 3 pi over 4. All right, for number 9, we got 2 parts. First part is finding where cosine is going to be 0. So what radian is the x value going to be 0 at? And that is on the top half of the unit circle, that's pi over 2. So we have to find the tangent of pi over 2. Well, if we look at the point for pi over 2, it's 0, 1. So you have the point of 0, 1 at pi over 2. Well, to find the tangent, you do 1 divided by 0, which would be undefined. That's really ugly. Let's write that better. Okay, so that would be your answer for that one. I don't know why it says 108, but it does. It's actually number 10. So this time you're finding the point value first, because it's the cosine of 7 pi over 4. So we're looking at your unit circle at 7 pi over 4. We're looking at the x term, which is going to be root 2 over 2. All right, and then we're looking for, on the right-hand side of the unit circle, what y value gives you root 2 over 2. And that's going to be pi over 4. Number 11's got a bunch of stuff going on. So the first one on the top half of the unit circle, because we're dealing with cosine, is where is negative 1/2, and that is going to be at 2 pi over 3. So that part's done. So now we have to do the sine, and then later we have to do the inverse cosine again. All right, so the sine of 2 pi over 3, you're looking at 2 pi over 3, what is the y value? It is root 3 over 2. Again, remember, you do these inside out, not outside in. So you start in the middle, at the very first part on the inside of the parentheses, and then you work your way out. All right, and then lastly, what is on the top half of the unit circle? What radian is the x value going to be at root 3 over 2? And that is pi over 6. All right, lastly, number 12, we have, for these inverse problems, we have what's the inverse of sine for root 3 over 2. Again, that's the right-hand side of the unit circle. It's going to be pi over 3. All right, and then looking at pi over 3, what's the x value of that radian? And that is 1/2. All right, so we're going to break this video into 2 pieces, otherwise it's going to be too long for YouTube. So that's the end of this first page. We'll start the page